Hello and welcome to episode 3 of Leveraging AI Applications in Subsurface Domain. Today we have the pleasure to have Sudeep Gupta, an alumni from ISM Dhanbad, joining us and also talking about his internship project. So it's very interesting to know about dispersion, seismic dispersion curves, a really interesting topic and quite technically challenging also. And this is where he has worked at University of Western Ontario during his internship last year, and he will be defining his project, his scope, and then we'll also have him brain pick because he has done also research in ML and deep learning. So he'll also talk about dive into that, and also the broader topics as we generally discuss here. So, without further ado, Sudeep, welcome to this is podcast episode 3, and welcome. So, can you
Thank
briefly
you.
describe? Can you briefly describe your research? The maybe it's a very difficult terminology, dispersion images. What do you mean by that? Maybe for that purpose, let's actually share a few images so the audience can know what is it about.
Right. So my topic broadly was to extract dispersion curves out of seismic dispersion images. I would be going into what these terms mean. So first of all, as we know, we need these to invert for surface wave velocity, which is basically a parameter used in site assessment. Now, why do we need site assessment? It is basically for civil engineering purposes. Like when, let's say, we are trying to make a building, and we need to test what the ground is, like whether the ground is, stable enough, or the soil is hard enough to, construct a
Mm-hmm.
building on it. So that is why we need certain parameters, geophysical parameters, which can convey to us whether the building would remain. And we can also use this in oil and gas exploration, as we know that S wave velocity can be used for pre-stack seismic inversion and AVO inversion. So the entire purpose of extracting these dispersion curves, which are essentially just frequency velocity relations. So
Mm-hmm.
as we know that velocity and frequency are related, and there is a curve which relates them, and this is called the dispersion curve. The seismic dispersion image, you can think of it as a heat map. As you can see on the screen here, the bluish picture, you can see
Mm-hmm.
that the heat map has the red spots.
Yeah.
In the cases, those are called the peak energy spots, and those are where the seismic dispersion curves lie. So in
Mm.
the acquisition phase, what we do is that we conduct a seismic survey. It is also called a multi-channel analysis seismic survey.
Mm-hmm.
We don't go very deep in this case, because we are only interested in for site assessment. So let's say just 30 meters or 50 meters, or at most 100 meters in the
Mm.
subsurface. And
Okay.
from that, there's some really technical and mathematical stuff that you need to do to get the dispersion images. And this is where my work came in, right? So getting to the from the dispersion image to the part where we get the frequency velocity curve, which you can see below
Yeah.
the processing,
Right.
uh, that is a tough process. Not just because it is done manually, because there is no software to do it. It is also tough because the dispersion images that we get are complex in nature, and
Mm-hmm.
yeah, for a human eye, it is very difficult to pick the right spots, the peak spots where the energy is maximum. So that's why it becomes very subjective, and also there are like thousands of, or tens of thousands of dispersion images like these. So we need
Mm-hmm.
to automate this process, and this is where my work came in. I simply had to take a lot of these dispersion images, train a deep neural network, a convolutional neural
Mm-hmm.
network, which can understand, to segment these images, the high
Mm-hmm.
energy spots, and then pick a dispersion curve out of it. And the final process is the inversion, which I was not involved in. I was only involved in picking the dispersion curve. So I know it might sound complex, but my task was fairly simple, and maybe that is why it sounds so complex, because I went really detailed into it. But
Uh-huh.
the name of the game is just going from the blue picture here to the curve there. That's it.
Okay. Okay. And what are we seeing here? So these are the images that you used for training, right?
That's correct. So, the
Okay.
purpose of keeping these images was to just show you the variety of images, seismic dispersion images that are available to us. So there's this
Mm-hmm.
simple dispersion images in which you have a single zone of, a high energy area. But there's also
Mm-hmm.
complex dispersion images in which you have, these multiple zones. So, for a human, it's very difficult to pick which is the correct zone, which would be, the fundamental mode of dispersion. And also
Mm-hmm.
there are different techniques from which you can get these dispersion images. One is the MASW technique that I talked about, and the other technique is the SPAC technique, which is a spatial autocorrelation technique. So just telling you about the
Mm-hmm.
complexity of the data set, like there are
Yeah.
simple images and there are complex images, and there are different techniques. So again, for a human to generalize among all and pick dispersion curves is really difficult. And my goal was to train a neural network which can generalize well among all these images and pick dispersion curves. So here on the right you can see the black images. Those are
Right.
the binary
The
segmentation images. So what it has done
mask.
is
Mm-hmm.
basically
Mm-hmm.
created masks, as you say
Right.
correctly. It has picked the area which have the high energy, and just everything else is black, and that is where the our dispersion curve is supposed to lie. In the bottom half at the right, I show you the images that have been picked. It might look very small here, but just to give you a general idea of how we pick the images and how it is displayed, how we pick the curves and how it is displayed in the dispersion images.
Mm-hmm.
So this is what I basically did, and in the middle you could see a U-shaped structure.
So
That
is
is,
that UNET? What
yeah,
model
that's
is that?
yeah,
UNET?
that is
Okay.
UNET. Yeah, you
Mm-hmm.
identified it correctly. It's actually state of the art in image segmentation. It has been
Mm-hmm.
widely used in biomedical segmentation. So in for doctors, it's also very doctors use computer vision a lot, and they also need to go through several medical images in which they have to segment the cancerous cells from non-cancerous cells, and in that this UNET has come in really handy. And actually
Mm-hmm.
that's why I could use it, because this was kind of similar. The segmentation problem was kind of similar. So you can also see like how domain adaptation has worked here. Like something that was used in biomedical image segmentation has come really handy in
Yeah.
geoscience. Yeah.
Most of the cases, there's a lot of domain adaptation you can kind of use. Like we also did a paper about domain adaptation in seismic image
Mhm.
segmentation. But yeah, this is what we also did kind of a while ago. This is nice. So I have a question. So, how much data did you have to use for the model training, and how was your let's say the accuracy for the masks? Maybe can you just give a
So
little bit on that?
yeah,
Idea on
so
that? Mm-hmm.
the data set was about 25,000 images.
Hmm.
Oh yeah,
Okay.
that was actually a lot. I could not train it on CPU. I had to get a GPU. Like I had to get a Google Colab Pro subscription, and had to get
Okay.
more GPU, because otherwise, this is essentially a big data problem. And since computer vision is involved, you need lots of processing power. So yeah,
Yeah.
25,000 images. And you asked me about you. Okay, what was the model performance like? So
Yeah.
I have not included here the model performance. I calculated it using, comparing the dispersion curves that were picked by hand, manually picked, and the dispersion curves
Mm-hmm.
which are model picked, and
Mm-hmm.
then just calculating the root mean squared error. So it varied for different images. For simple images like the simple dispersion images, it was really less. But when it went to complex dispersion images, we could see that okay, even the model was not doing as well. So it varies. I mean, that's all I could comment.
Okay.
Yeah.
S- cool. So, what is and then and you actually, yeah, you mentioned you compared with how the manually it was picked, right? And
Right.
what is this research still ongoing in the university, or it's like it's or it has taken a different direction, this research?
I'm sure it is going on because
Okay.
this is definitely not the best model out there. Uh, uh, the model that I trained did pretty well. I trained it on complex dispersion images, which to the best of my knowledge has not happened in the community before. But
Mm-hmm.
again, like I said, that in complex dispersion images, the model performance was not as good. So
Yeah, okay.
computer vision is always evolving. The processing power is always
It's yeah,
evolving.
you can
Yeah,
use transformers and all
yeah. We
new
are getting different model
architectures, right?
architectures, right?
Yeah. So I have a question about your data set. I mean, it's very interesting, the problem. So you mentioned there's 25,000 data. So do you have to, how much time did you spend in pre-processing or picking the and getting the right data set from your data, bunch of data?
Yeah.
Or
So this
where
is
was it already there?
yeah, this is where I got really lucky. So there was already this paper which has done a similar work on simple dispersion images,
Mm-hmm.
and they had the data set. The 25,000 that I'm talking about was on simple dispersion images. So the author was kind enough to provide me the training data set for it,
Oh,
uh, and
uh-huh.
this is actually synthetically generated. So
Okay,
so the
I see.
top top two, three, I think the one on the top left is synthetically generated, and then
Mm-hmm.
I actually added complex dispersion images, which were real dispersion images from our project, and I kind of used transfer learning. So I
Hmm.
trained my model on these simple dispersion images, which for which the data set was huge. And since I had very less complex dispersion images, because they were only like 100, 150 in total, so I couldn't really, get any meaningful training out of them. So
Training
what
out
I
of
had to,
okay.
yeah, what I had to do was use, the concept of transfer learning because,
Yeah.
the domains are pretty similar. So whatever features my segmentation model learns in simple dispersion images, I hope that it could, learn them or use them
Uh,
to extract
right.
curves out of complex dispersion images. Yeah.
Cool, cool. Very, very nice. Very interesting topic. Yeah, so I think we did a lot of discussion on that. So let's come back to what you are doing now. So you will be joining ONGC, right, as a geophysicist office, right? Very
I will
soon.
be. Yeah. That's the plan. Yeah.
Yeah, and are you really happy about it, right? Are you really excited about it? Joining in your own domain, because I know these days many geophysicists are moving in away from geophysics. So
Yeah, certainly.
how is it? Let's just stop sharing and let me go back to the screen. Yeah. So how do
So,
you feel about it?
yeah, I mean, certainly very stoked about it. Primarily, the reason is because whatever I've done a couple of research internships. Uh,
Mm-hmm.
and, as I said, both internships have been in the research domain. So I've had a lot of exposure to academia. I've, spent the last 5 years in a college environment. So what I wanted was to, get an experience of the industry itself. uh,
Mm-hmm.
there was, in fact, I'm still going through this dilemma whether I should go into research or not, whether I should stay in like core geophysics or maybe move into more AI ML related fields. But I before going into academia, I always wanted to get a feel of how industry is. So definitely stoked about going to getting an industry experience. Yeah.
Great, great. And how is it? How is this research, or maybe I would say, how is the adaptation of deep learning going in ONGC? Do you have any idea, or is it there's research going on, or you because you haven't joined, you don't know much about it?
Yeah, I would say that is the answer. Since I haven't joined, I don't know much about it. Like
Yeah,
what's
but
to
you
be say.
don't know from other like people who are in the company itself. You still don't know about it, right? The how
Yeah,
they're okay.
yeah,
Sounds good. Yeah, so we should know more from you about how industries are adapting to it. So what is by the way your opinion of industries adapting like new technologies, I'd say, Deep learning, of course, is there. Then there can be like new visualizations like Unreal Engine and things like that. So, what is your view on that? Like, do you think that this adaptation will happen, or will it bring value to industries, or it might be the way they are going? It's okay, fine for now.
So do you mean specific to the oil and gas industry, or like?
Yeah, let's be specific to the oil and gas industry since we are in that domain right now, discussing that. Yeah.
Yeah, I think the oil and gas industry should definitely, get more of its, hands dirty in these new technologies. We know that it has been a little, tough to push these technologies into the oil and gas industry because it's traditionally, more old school and likes to do things in those ways. But I think the evolution is certainly happening. Maybe not in the developing nations as such, like in India. But definitely there are companies in the US which are using, leveraging the data that is available. And there's, so much data available in this field. Just like every well log out there, every seismic survey out there, or all those surveys that you do to, just assess or explore for oil and gas. It just gives out so much data, and you can, use this data to optimize operations. That is one thing to, save dollars on the go. And also one of the most important things, the elephant in the room for the industry, carbon emissions. So just using this data and seeing how you can optimize operations and produce more efficiently, so that you can save more money, and at the same time also emit less carbon dioxide into the atmosphere.
Into the
So
atmosphere. Yeah, for
yeah,
sure, for sure. Yeah, so then like to brief you a little bit about EarthScan, actually in EarthScan we do exactly that. We help oil and gas industry to leverage AI into their applications. So
mhm,
yeah, because one of the reasons that we think is important is, as you rightly mentioned, is doing your lowering your carbon footprint, right? And of course, scalability, and then making use of many unknown data, right? That's in the industry, as you mentioned, like there's so much data, and manually picking is of course not one of the ways that
right.
you should go about. Yeah, yeah, that's really cool. Yeah, and so also there is a, I mean, it's always a debate over there, right? So moving from conventional into renewable, right? So what is your opinion about that? I mean, do you think conventional will not exist in, like, let's say 30 years from now, or there is a balance between these two forms of energy? What do you think? What's your
Yeah, I
opinion?
think ideally it should not exist because the way the temperatures are rising and the way the climate is changing, we really need to find new ways to produce our energy and meet our energy demands, which do not emit as much carbon dioxide. But the thing is that oil and gas, although however bad it might seem for the world, it is also important to meet the growing energy demands, because the developing nations, they are getting more power hungry by the passing year. And with the rising population and increasing standard of life, the energy demand is just going to soar, and soar really high. Okay, so renewables are definitely into the mix now. But
Mm-hmm.
again, to meet these demands, it would be impossible to just focus on renewables. But at the same time, we also have to cut down on our oil and gas production, because that would make the world unlivable. So it's really tricky. It's a really tricky problem. I mean,
Mm-hmm.
everyone really understands that. So there are methods in the industry like carbon capture and sequestration,
Yeah.
which
Mm-hmm.
are aiming to at least offset a portion of the carbon dioxide emitted because of this oil and gas production. So that could be a way. But yeah, definitely I think the companies should be focusing more and more on diversifying their assets, and investing more in renewable energy. I mean, that's incredibly important for the world.
Cool, cool. Thanks for knowing about your opinion. Yeah, this is a common question. People I know there's two sides to the coin, but anyway, it's good that to know about it. So I think with this we had a nice podcast, and I think my electricity is flickering. But anyway, um, yeah, thanks, Sudeep. It was really nice that you shared the research with us, and stay tuned. We'll be posting this on YouTube soon. And thanks a lot. Thank you. Okay,
Thank you so
bye
much for
for
having
now.
me. It was a pleasure. Yeah, bye.
Yeah, bye.